So, good afternoon. I'm Ed Lopez, security architect for Corsa. The quick 15-second blurb there, Corsa makes large programmable switches, and they're an Ottawa, Canada-based company. Who am I? Because a lot of people don't know me. For the past 20 years, I've been involved heavily in network security, basically selling, deploying, and even building very, very large middle boxes. In fact, this time last year, I was vice president of product management for Fortinet for carrier solutions. And one thing I can tell you after 20 plus years, I hate middle boxes. They're terrible, okay? So, that said, I want to talk today about contextual forwarding. And what do I mean about contextual forwarding? Well, one thing to put this thing into context, per se, is that we're dealing with a lot of pressures. Some of it, and the example I used in this in the abstract was geopolitical pressure. There were others, but the idea here is that now, for example, in the news, we see after the London Bridge attack, hey, here's the UK Prime Minister saying we have to regulate the internet. You know, if anybody's been keeping track of the news regarding what's going on in the Middle East, you know, and what's going on in Qatar. You know, it's interesting that today, if anybody's going to Dubai, just to let you know, the penalty for supporting Qatar in social media in Dubai is 15 years in prison. So, you know, the point is, this is not meant to be a political talk. What it's meant to indicate is that there are pressures that are being put, you know, from government, from regulation, and even from our customers and businesses associated with the ability to look at the content and context of the traffic that we're forwarding. Of course, you know, as network operators, you're not, you know, you want to pass the packets. You don't want to read them per se. And like I said, much of this pressure is currently directed towards content providers, application service providers, and even device manufacturers. But in many cases, government intervention into peering is now being considered. So the real question is, if we had to, as peering points become more specialized, more associated with you know, application-specific, content-specific, what have you, if we had to, could we scale the ability to contextually forward traffic to meet peering performance? And what I mean by contextual forwarding is the ability to use programmable data planes to forward packets based on traffic analysis or inspected content. So the idea of decoupling these middle boxes to be able to scale the solutions to meet the architectural requirements, because middle boxes are terrible forwarding planes. They don't integrate well. They generally tend to be very problematic. But as this slide is showing, the ability to decouple security analytics, make use of analytics, and this includes DDoS, the ability to be able to direct traffic of interest to deep packet inspectors that are on the side, as near line rather than inline, and the ability to perform all of this on a programmable forwarding plane that integrates correctly into our networking environments is a key goal here. So the idea of, you know, in a traditional, you know, just a very simplified, of course, peer standpoint here, the idea here is, again, that there is, of course, flow capture data. We receive this data all the time and send it to analytic engines. This is, you know, the net flow, the S flow, the whole 9 yards. We also have event data. Okay, this event data may be coming from our customers, it may be coming from various sources, but this is, you know, clear event, hey, I see something, I'm trying to say something, kind of information. A lot of this could be syslog data, it could be various different types of event data coming into our analytics. The other thing is there's quite a bit in terms of security intelligence feeds. There's a lot of information that's out there, you know, everything from, you know, anything from dynamic blacklist, whitelist, you know, botnet command and control, DNS information, the whole 9 yards. Information that may be relevant to our goal of trying to look at traffic in context. So if we have all of this information, you know, like I said, see something, say something, okay, we have the analytics, we have the capability of getting these feeds, but how do we do something? How do we say, okay, based on this, we can take action based on the context of traffic. So initially, there have been a lot of attempts, right? We all know about black holing. We all know about BGP flow spec. These are all capabilities that we try to impose upon our networking architectures. But another concept would be the ability to use programmable, bare metal switches, programmable switches, to be able to enforce traffic. The idea here is this device's sole purpose is to create a virtual layer 1 wire and be able to enforce ACLs and or programmable flow rules based on contextual information. It sounds a lot like SDN, but one thing that we're trying to avoid is complexity. We're trying to avoid complexity of implementation. We're trying to make this work for us. So rather than dealing with all of the intricacies of SDN and the like, the better path is to simply make use of standardized APIs. Look at it from an implementation problem. Be able to say, look, we support RESTful APIs in our platforms, in our analytics platforms. We support FlowSpec. We support syslog. There are others, the IETF. We talk quite a bit about DOTS and interface to network security functions. And in fact, I'm an author of the framework document on I2NSF at the IETF. So the idea of being able to, instead of making it a massive programming problem, be able to convert our data through standardized APIs into dynamic ACLs and into programmable flow rules makes this work. Now, this allows us to do things like PAX, block, or rate limit traffic. The other thing that we can do, and of course this is supported in these methodologies, including BGP flow spec, is the ability to redirect traffic. The ability to say, hey, there's a rule in place, there's suspect traffic out there, I want to send it to a deep packet inspector for some reason. And therefore be able to sideline that, and it does two things for us. First of all, it gets that engine out of the way. It's used when it's needed to be used, but it's out of the way. The second thing it does is, because that inline inspection engine is no longer concerned about making a routing or forwarding decision, it's pretty simple, right? One interface in, one interface out. It allows us to, one, virtualize and scale these solutions. So, two, it makes them quantitatively stable relative to performance, because they do the same thing on all packets they receive. So this allows us the idea, or the concept of being able to apply analytics and even potentially apply direct packet classification onto the problem of trying to forward traffic in context. So the idea of an enforcer, the ability to create this path-centric virtual wire using dynamic ACLs and multi-tuple programmable flow rules. Unlike SDN, like I mentioned, using standardized API. And DevOps integration is key. One thing that we want to do here is we want to make sure that we're incorporating it in our automation, our orchestration, our monitoring solutions. And the enforcers can certainly directly mitigate traffic at wireline rates and redirect traffic to nearline engines. So this allows us to virtualize those solutions, place them on open compute platforms, be able to load balance, be able to amplify the value of security intelligence, basically get the packet processing that's CPU intensive out of the direct path and sideline it. Open is very key to these solutions. Like I said, my company manufactures programmable floating points. I'm glad to talk to anybody about it. But the truth is, this needs to be something that we're working on an open basis. The use of standardized protocols, APIs, the ability to decouple into open compute CPU analytics and open networking, be able to make use and be able to convert sources of intelligence feeds and DevOps integration. That's my pitch. So thank you very much for your attention.